This record. Okay. Right. It's also we can use the hypothesis test. You can use the confidence interval also. Right? We can use the confidence interval. We have the minimum and maximum or lower upper bound for this your process. And also you can use the hypothesis test. The same thing. You can use hypothesis test also. For the hypothesis test, we would like to check your mean, your variance, or your proportion. Your mean is in the acceptable range or not. Your variance is in the acceptable range or not. We apply the technique of hypothesis test. Right? Usually we have two hypotheses. Hypothesis is the null hypothesis and alternative hypothesis. For that case, for example, right, for this case, we consider the solid covalent. Solid covalent for the escape system in the airplane. So that we would like to check the burning rate of solid covalent. That's like the burning rate of solid covalent. For that check, we would like to compare between mu equal to 50 centimeter per second. This is the rate of burning. That's right, rate of burning in length per time. In length per time. Or alternative that mu not equal to 50, equal or not equal. But sometimes you get the mu equal to 49 compared with 50. This equal or not? The number is not equal, but statistically it may be equal. Because this 50, this 40 is come from the average value from the data. That's the average value from the data. It may be some random error for that case. We will compare based on statistically. We don't worry about the number. It may be 49 equal to 50. That's possible because it's based on statistics. If you would like to check, you mean that you collect from data equal or not equal the standard, equal or not equal the spec. That's right. And we have another hypothesis. It may be equal. Usually we pick the null hypothesis equal. The null hypothesis we pick is equal sign. This equal. This is fixed. This is fixed. This is also fixed. And only S1, that's why we have three choice. Equal, sorry, not equal. Or less than or greater than. It's a possible three here. But null hypothesis S0 we pick as equal sign. Equal sign. We only check we will accept S0 or reject S0. If you accept S0, that means you accept S1. This is the hypothesis here. If you accept S0, that means mu equal to 50. The main value that you collect from the sample equal to your standard, equal to your spec. If you reject S0, that means you accept S1. For this case, it's less than 50. For this case, it's greater than 50. But for this case, it's not equal to 50. This is the conclusion. We have three conclusions. Equal or not equal, greater than or less than. Sometimes I didn't talk for all tonight. This is the hypothesis that I use. This is the decision that for the error that's occurred in the hypothesis test. We have about 4. Decision failed to reject S0. Failed to reject S0. Accept S0. But we use the word is quite completely. Fail to reject S0, that means accept S0. This is accept S0. This is accept S0. This is reject S0. Reject S0 means accept S1. Okay, reject accept S1. We have only S0 and S0. Okay, we have some error. If we accept S0 and S0 is true, that's correct. No error. So if the S0 is true, and then you get hypothesis, you conclude that you accept S0, that's correct. There is no error. There is no error. But if you accept S0, but S0 is false, this is error. What happened? We have to say. Because S0 is not correct, but you accept. This is the error. Because this is type 2 error. Type 2 error. And the case 3, you reject H0, but H0 is true. It's true, but you reject. This is error. It's somehow error. And the last one, you reject H0. H0 is not okay. Because it's not correct. You reject it. Correct. That's right. This is okay. For conclusion, we have 2 errors: type 1 error and type 2 error. There's a type 1 error. You reject H0, but H0 is correct. This is sometimes we found this out. Because this is the alpha or significant level that we talk about. This is the type 1 error. This is alpha. Reject H0 when H0 is T, like this. And also, if we contract the critical curve, for this case, if we consider the normal distribution, that's right, the normal distribution. If we take the on 2 side test, upper bound and lower bound, right? If your data in this region, it's the same confidence interval, right? We have this is upper bound, this is lower bound. If your data in this region, except that region, okay, we accept your data is meet the standard. If it's located in the reject region like this, upper or lower, for this you reject. That's right. Your data is not equal if you compare between equal and unequal. Right, correct. This for example. Maybe I will show you some example. We have some power of statistics in terms of type 2 error. Type 2 error we represent by beta, but type 1 error we represent by alpha. And also beta we is the power of the hypothesis case. 1 minus beta. Okay, I conclude that we have 2 side tests. Right, this is 2 side test, equal and unequal. This is 1 side test, equal and greater than, or equal and less than. From previously, if you talk about the machine filling in the bottom, right, we check the greater than or less than, because we only to check the maximum limit. What is the overfill that we can access for that test? We have only 3 points for the test. Right. Unequal or not equal, greater than and less than. And also we found that in English word it may be less than, it may be greater than, it may be at least. What does it mean at least? At least. Greater than or equal, right? At least. Should be greater than or equal. It's not less than, for example. Proceed is greater than. It's many words in English. You have to take it carefully. But sometimes we talk about the at least, we talk about the greater than, we talk about less than, we talk about the superior to, it takes that the proceed. That's how that is meaning. Okay. Okay, I will show you the step to make a hypothesis test. But I will show you in the calculation and also in the minute count. Okay, I have some minute count. Okay, for the step 1, right, you have to identify which parameter you would like to test. You would like to test on mean, you would like to test on variance, or you would like to test on proportion. And for previous, I usually talk to you in vector degree only in mean time. But in the system, we can represent in variance, represent in proportion. But for in calculation, we talk in proportion and variance also. Okay, the first step, you have to identify which parameter you would like to test. You would like to check the mean of your property with the standard, right, or with the specification. The step 2 or second step. Right? Step 2, you have to identify null hypothesis. For this part, I will pick null hypothesis is equal. Right? You would like to get the mean equal to the spec, the mean equal to the standard, the mean equal to the last day, mean distribution. Okay, this is the null hypothesis. You have to specify S0. How about S1? The third step. Step 3, you have to identify S1. You should write to S1 mean equal is hypothesis. No. Hypothesis means not equal or less than or greater than. You have 3 parts. Not equal, less than or greater than. It depends on your system. Sometimes you would like to check on minimum and maximum, but sometimes you would like to check is at least, for example, it's not greater than, for example. If it's not greater than, means you have to check less than and equal, right? Less than and equal, not greater than. Because we have to mean it's not greater than. That's right. The error not greater than has been less than and equal. You have to translate from word statement to the mathematics. Mathematics, that's right. Okay. And after you identify S0, S1, and then choose the significant level. This is the percent confidence. Usually in engineering, you use 95%. Alpha equals to 0.05. But sometimes you can specify it 90%, 80%, 99%. But commonly in engineering, we use 95%. Only we accept 5% error. We accept 5% error. Okay, after you choose the alpha, and then you calculate appropriate statistics. If you use T distribution or not, use T distribution, size square, or F10. Is it depend on the property, depend on the condition? If a big data, okay, we can use the T statistics. If the data is small, okay, we can use T distribution. If you test based on variance, maybe use size square, for example. You have to choose the appropriate statistics. And then you calculate the critical region and except regions. That's right, critical region and except region. Number 6. And number 7, compute or calculate the sample quantity. That's right, sample quantity. You calculate the size square, you calculate the T test, you calculate the C test. That you have to C0, T0, size 0 compared to the critical region. And the last, you compare your test statistics and conclude you accept or reject. Right? If you accept, that means you accept S0. Right? If you reject, that means you reject S0, you accept S1. You have only S0 and S1. Reject S0 means accept S1, for example. Okay. I think for the first case, we have many cases. The first case, if your data is normal distribution. If your data is normal distribution, that means a big data and you know variance of population. Big data and no variance, we use C distribution. We use C distribution. And the big data, you don't know variance, you use C distribution also. That's right. Use C distribution also, you calculate that sample variance instead of the population variance. And if the data is small, you use T distribution. I will talk to this later. Okay, the first case, if you know variance and normal distribution that are big data, you use T distribution. I conclude in this slide. First picture shows two-side test. The second one is upper test, lower test. And also we conclude for this alternative choice. For the first one, if the two-side test, that's right. This is for normal. We have to identify the accept region. This is the reject region. Reject region alpha divided to. You have to calculate C alpha 2 minus C alpha 2. Right. And for this case, the two-side case, we have H0 mu equal to mu 0. Mu 0 is your standard, your spec. That's right, your standard spec. Okay. And S1 is not equal. Right. Not equal. And then you will reject S0 when C0 greater than C alpha over 2 or C0 less than minus C alpha over 2. That means you reject it in this region, that's right. Or in this region, we have to show this region, we reject. That you calculate C alpha over 2. You know C alpha over 2, you know minus C alpha over 2. That's right. If C alpha 2 is in the rejected region, okay, you reject S0, you accept S1. And for the second case, one side test, right? For one side test for this, right? This should be greater than mu equal to mu zero or mu greater than mu zero. Right? You will reject mean z zero is greater than z alpha. And this is for upper one. We have only three cases. Okay. Okay, for the first example, this is we design the solid propellant. Okay. Like we use this in the system of air-fuel aspect system. The burning rate of this propellant is an important product characteristic. The spec requires that mean burning rate must be 50 centimeters per second. This is the spec. The spec we need 50 centimeters per second, the burning rate. And also for this sample, we know the population variance or population standard deviation is sigma equal to 2. This is the population. We know you can use distribution. You use distribution. For this case, the experimenter designed to rectify type 1 error equal to 0.05. This is 95% confidence interval. With sampling from population is 25 sample. We sample 25 sample. And then we measure the average of your sample is 51.3 centimeters. What conclusion should be drawn? For this case, the spec is 50. For this case, you can understand what conclusion should be drawn. That means we would like conclude is equal to spec or not equal. This is equal to spec or not equal. That means 51.3 equal to 50 or not equal to 50. That means you should S0 equal 51.3 equal to 50. S1 51.3 not equal to 50. This is the two tests. S0 equal to 50. S1 greater than not equal to 50. Right. And then in step 1, we would like to get on mean or average burning rate. As I talked to you from the problem statement, you can calculate S0 equal to 50. S1 not equal to 50. You find the number is not equal, right? Because the number is from the average. As I talked to you, we have some the error. The statistic you can equal or not. You don't know about the number, because number from the data. And we use alpha 0.05. For this case, we should see test. We use this test. We use this parameter to calculate. Because this is no sigma. We know variance. If you know variance, you don't worry about the number of samples. It's big data or small data, don't worry. If you know variance of population. Okay, for this case, we calculate at alpha equal to 0.05. And then you get alpha O2 equal to what? 0.025, right? Okay, and then you can calculate C at 0.025 equal to 1.96. Because you use this a lot. You use it a lot. It's the same number. But I see alpha O2 equal to 0.05. You open from table or open from Excel. You get C equal to 1.96. And minus equal to minus 1.96. That means the reject region it should be minus 1.96. And this is 1.96. Right? You calculate C0 is less than minus 1.96, you reject. You calculate C0 is greater than 1.96, you reject. If C0 is between 1.96 and minus 1.96, you accept S0. That's the technique. Okay, this is we consider accept and reject. And then you calculate the statistic data. For this case, we know X bar, we know sigma. You substitute X bar sigma into this. Right? You get that C0 equal to 3.25. What is it? 3.25 in this zone, right? Reject. Right? Reject. Because it's greater than 1.96. It's greater than 1.96. For this case, you reject S0, but you accept S1. What does it mean? The conclusion that the burning rate of your sample is not equal 50. That's right. It's not in the spec. That's right. It's not in the spec. And also, if you would like to calculate CI, you can show by CI. You calculate the CI of it is in the, it's not in the range, it's not the same. Okay. You have two techniques. Calculate by previous technique, convert into also, or you calculate based on the hypothesis case. For this case, we conclude that the mean burning rate different from 50 centimeters per second. That's right, centimeters per second. Okay, this conclusion. And usually in the program, we use another technique. We calculate based on p-value. Right, I will show the p-value. We usually in any program used in the computer program, we use the p-value. P-value is the smallest level significant. That's what reject of the universal. If the p-value is less than alpha, we reject. If the p-value is less than alpha, we reject. If the p-value is greater than alpha, we accept. That's right, for this case. But for this, we show you how to calculate p-value for normal distribution, for C distribution. If you test based on two-side test, we use this to multiply 1 minus probability at C0. If you know C0 for this, you know 3.25. You calculate the probability at 3.25. And 1 minus probably multiply to you get p-value. And then you compare p-value and alpha. If p-value greater than alpha, you accept S0. If p-value less than alpha, you reject S0. Right. But for the next case, if you calculate based on upper tail, p-value equal to 1 minus probability at C0. If a lower tail, probability of p-value equal to probability at C0. Right. But in the program calculate this automatically. I will show you in minutes for the next two slides. Okay, we will check the p-value for this case. P-value for this case equal to 2 multiply 1 minus probability at 3.25. If you use Excel, it will norm S, that's right, distribution, that's right, not the distribution. You calculate it and then you calculate 0.0012. Okay, for this case. This is how to show the hypothesis. You can check your data. Check your like equal or not equal is greater than or less than. Like this. Okay. I will show you some Excel files for the minute. I think if you open your computer, you can follow me. You have to open also. You have to know the data. Let's start. I think it's a new version and old version is something a little bit on the Windows release out, but the toolbar is the same. You can use the Minitab to calculate the hypothesis test, and also I think you have some calculate the number of samples. Okay, we can. What is the number of samples that when you do the experiment that I will calculate? We would like to get this mean and how many numbers and predict by the Minitab also. Okay, we look at the first example by. Right, for this, we need a short description about the, for this case, we use the stat. We use the stat. You can you need to calculate the number. You can input your data that time. If you don't know the mean, if you know the mean, you can put the mean directly. If you have the data, you can put the data. But have to do it. The program will be calculate your mean, you calculate your variance automatically for you. We have to this example in the slide. But for the first example, we know the mean. We go to the stat. And also we go to basic statistics. We have many one sample size test, one sample t test, two sample t and pair. I will talk to you all of this. For this case is one sample, right? We have one sample C test. If you would like to calculate the number of samples, you go to power and sample size. If you would like to calculate the number of samples you would like to collect, if you would like to get this property. Okay, for this case, we go to the basic statistics and go to the first one simple C test. Because we do this, you use C distribution. You click to the distribution. Okay. For this, if you have the data in spreadsheet, you collect it. If you have the summary data, you have the mean, you have the sample already, you choose this one. For this example, we know sample size, we know sample mean. We know sample size, we know sample mean. For this case, we know the sample size is 25. The mean is 51.3. The standard deviation we know is 2. We would like to perform hypothesis test. The standard of the spec is 50. This is the hypothesis mean is 50. We like to get 51.3 and 50. Okay, this is the first step. And then you click option. The confidence interval is alpha equal to 5. That means CI equal to 95%. This is we have only 3 choice. Less than, not equal, or greater than. But for it is not equal, right? The mean not. The mean is 51.3. Hypothesis test is 50. Right? Okay. Click OK. And then you can, okay, we show you the result in this window. One simple test. Mu equal to 50 and not equal to 50. Because the program will summarize the technique. We test on mu equal to 50 and mu not equal to 50. And we know the standard deviation is 2. For this test, it calculates both confidence interval and test. For this case, the number is 25, mean is 51.3. And also we have confidence interval. Confidence interval. And also we know T value is 3.25 and P value is 0.01. Right? You found that P value 0.001 and alpha is 0.05. P value less than alpha, right? You have to compute by yourself. Because this is calculate all value for you. P value equal to 0.001. Less than 0.05, less than alpha. Okay, the conclusion is the same. Right? P value that you calculate from Excel or you calculate by manual. 0.012, right? It's the same. 0.012. And for this case, we need it because P value is less than alpha. And the formula we also need it. Right? And also, if you do add the confidence interval as I talked to you previously, the minimum is 50.516. The maximum is 52.06. You see the percent CI is not include 50. That's right. Percent CI of the sample is not include 50. That means it's not equal 50. If 50 include in the percent CI, okay, that is equal. Right. For this case, 95% CI of your sample is 50.516 and 52. That's right. This is that means the 51.3 is between this confidence interval. Right. But you compare with 50, right? 50 is not included, is it blank? You can conclude that 50 and 51 quality not equal. You can do for this by confidence interval or by hypothesis test. This show you both hypothesis test and confidence interval in your data. For this case, you can conclude that. Okay. This for only this step. Have any questions? No problem, huh? If you have some questions. Okay. What if you do like this, we have the data to conclude. You have to analyze the data correctly. Again, because the confidence interval of your sample, right, between 50.5 and 52, but it's not include 50. And also you can conclude that it's not equal and or greater than 50. That's right. 51.0 greater than 50. You can conclude this also. Right, because the CI is greater than 50. For that case, if your QC, you have to check what happened. If you check with the spec, but your data is greater than spec, right? You have to check your property, your process, that's right. But for that case, you have to check with your acceptable error. You have to check the error is error, but the error is acceptable or not. What percent error you accept? That's right. For that case, you have to calculate the error. For the next one. Okay. And also for this case, I would like you confidence interval I talked already. That's right. For this case, I talked this already from the data because it's not in the range. For this case, 50.5 to 52.08. That's the same conclusion. And the next step, if you would like to calculate sample size or type 2 error, in this I show you the technique to calculate that for sample size. The sample size is in terms of beta. Beta is type 2 error. Or 1 minus beta is power of the statistic or power of hypothesis test. I will show you the equation. It's many slides, but sometimes I did not focus on that. This case, how to calculate beta. If you know beta, you can calculate n. For this sample size, you can estimate n like this. Number of samples, you can estimate number of samples. This is for two side test. And the bottom one is one side test. You can look at it the same one, except term of alpha. Term of alpha.เมื่อวานมีตัวแทนประกันเอพูดเพราะมากคนไหนกลัวว่าเราถือว่าเป็นเรื่องที่พูดเพราะจริงๆนะพูดด้วยความเกรงใจโอเคนะดิสเอ็นอาจารย์ก็เป็นลูกค้าอยู่แล้วเขาก็กลัวว่าเราจะไม่รับสายเขาพูดเพราะมากไม่คิดว่าจะเพราะกันได้ But this is for number of sample for two side test. It is alpha divided by 2, right? But for this case, it's alpha. You can use this equation to estimate the number of samples. This is the minimum number. Minimum number. For the previous example, right, we have the equation n equal to C alpha over 2 and C beta. What beta is the number of power we use like 90% for this. It's 90%. And you know sigma. And you know the difference. Right? Delta is the difference between you test is 51 and 50. The difference is 1, the alpha to beta. You know C alpha over 2, right? C beta. This is you open from table or Excel. That's fine. And then you substitute, you get around 42 samples. That's right, 42 samples. If you would like to get about 95% confidence and this value, you need at least 42 samples. When you sampling the data from the population. Right. If you use Minitab, in Minitab. We go to stat also, but this is go to power and sample size. We talk about power because power is represented by beta, type 2 error, and sample size. Okay, for this case, also one sample C distribution. Okay. For this case, you can type only two. It needs only two. If you know sample size, you calculate power. If you know difference and power, you calculate sample size. For this case, we need only two data. This and this, or this and this. For this example, we know beta and we know difference. You calculate number of sample or sample size. Okay, for this case, we know the difference is 1, the size 61 minus 50. We use the power value is 90% of beta equal to 0.1. That is 90%, 0.9. And your standard deviation is 2, right, for this. And for this case, we test based on less than, not equal, or greater than. Is it not equal? Right, and we use the alpha equal to 0.05. Okay, if you need that, it's okay. If you would like to check your graph, you would like to plot the graph or not, fine. Okay, if you know, okay, then we okay. Fine. And then from this case, the one simple C test, we test known equal and not equal. Right? Alpha equal to 0.75, power is known not different. And then the conclusion, the difference is 1. Sample size should be 43, right? 33. And power is 0.9. That's correct. But for the calculator, it becomes only one error, right? Because it is estimate from the calculation about 42. Number 1 okay. This is from the Minitab is about 42. We need at least 42. And we have another technique, but I do not talk. For this, we use the equation to calculate numbers to estimate by equation. Or you can estimate from curve. You can use the curve to estimate, and but it is only because we input in program already, we input or in equation already, or you can estimate from this curve. Like this is curve for the alpha equal to 0.05. If you know beta, you know type 2 error. You know type 2 error. You know the difference. The difference is defined as mu minus mu zero divided by sigma, or delta divided by sigma. You use the absolute, right? You know the, you know beta, you can estimate n. N is n equal to 1, equal to 2, 3, 4, 5, 6, like this. If you know d equal to 1, and you know beta equal to 0.2, you get n between 8 and 7. For example, it's approximately 8. You can use this curve also. This is curve for alpha 0.01. This is at any alpha. Before alpha. Before this, if you know the variant or you don't know the variant, if your data is not, if you know the variant, and also the data is a big data, you should use the variant of sample. You should use the variant sample. But for this case, if you don't know variant, it should be unknown. Use unknown variant, unknown variant. You use the distribution if data is a big data. I think it's better than 30 is okay. Right. For this, I should be 30 is 40. 30 is okay to use the C-distribution in a big data. Big data. You use the same equation, but you change from sigma to S, from sigma to S. You use the statistic test is the same equation, but you replace sigma by S. This sigma is the population value. For that case, the big data, we use the sample value. Sample value that means you collect 20 samples, 30 samples, you calculate the value of the sample and substitute in this equation. Usually we know sample, we don't know sigma in the most case. We use the same equation, but instead of sigma and S only. For the next one, we will talk about the case of we use T-distribution for small data. That's right. For a small data, it's maybe n less than 30. N is small. For this case, n is small. If you don't know variance, right? If you don't know variance, if you know variance, okay, you use T-distribution. You know, a population variance, you use T-distribution. It doesn't matter if big data or small data, but if you know variance of the population. Okay. For this case, we do the same two-side test, upper and lower bound. Upper and lower bound, but we use T-distribution for small data. For small data, it's n less than 30 and unknown variance. Unknown variance. For this case, the definition of T-distribution and sensitivity is the same. X bar minus mu divided by S divided by square root. And the equation is similar. Similar, not the same. Why similar, not the same? Because you S instead of sigma. And for this case, we use the two-side test. The critical region should be this: T alpha over 2 n minus 1 minus T alpha over 2 n minus 1. This is the upper, this is the lower, and also this. But for this case, we use T-distribution instead of C-distribution only. The equation that we use is similar. Is we have some case about the strength, the material is steel. Okay, I have 15 sample, right? 15 sample of the measure the coefficient of restitution emission for this case. This is the cost, right? Okay. And we use the test based on alpha 0.05. We would like to check the mean coefficient exceed 0.82. Exceed, what is negative? It's greater than or not, right? Exceed means it's greater than. You would like to check your data is greater than or not. That means no hypothesis equal to 0.82. And alternative is greater than 0.82. For this case, from the meaning of this word. We would like to claim that the mean coefficient exceeds 0.28. Equal or greater than for this case. And this data, at the top, we don't know the variance, and data less than 30. Data less than 30, we use T-distribution. For this case, you calculate X bar, you calculate S, you calculate X bar, you calculate S, and we use the equation like this. This is for one side case. We use this case. That's right. This case. For this. And also we check only the normal one. For this case, we test based on mean mu. Known is equals, right? S1 is greater than. That means for this case, we want to reject S0. Why? This is objective. We want to reject S0 because we would like to test you would like to claim that this is greater than 0.82. That means the objective is would like to reject. I would like to reject. If it's not rejected, that is some property, that is some problem, that is some problem. Okay. And alpha 0.05 we use t test. This is the t-test. X bar minus mu 0. Okay. And then the reject reason because you use t alpha t 0.05 to 1.761. Open form table or open form Excel. Okay, and then you calculate the t0. You know X bar, you know S. Mu 0 is the hypothesis mean, that's right, hypothesis mean 0.82. N equal to 50. Yeah. And then you get 2.72. Right. The reject reason is this 1.7161, right? This is the reject reason. Because the 2.7 is in this reason, it's rejected. Okay, you would like to reject this reject. That's right. That means the coefficient is greater than 0.82. Right? 0.82 because T0 greater than the reject reason or greater than this critical value. 2.72 greater than 1.761. That you reject at 0. You accept at 1. That's right. That means the coefficient of distribution is exceed 0.2 or greater than 0.2. This I show you to T distribution to calculate like T distribution. You calculate the P value from T distribution. It's 1 tail and 2 tail. But it can be calculated on 1 tail. P value equal to 0.008 is less than alpha. 0.008 less than alpha 0.05. You reject. Okay, you reject. For this example, we did not show you because I can show you, but for this I have to put all data in the Excel. I did not put the data because this we show you how to use based on you do not calculate the mean and variance. The program calculates for you. You have to put all data in the spreadsheet. Put all data in the spreadsheet. If you, for this case, you have to put all data, 15 of data in the spreadsheet. You put all this. Right. I do not do this. Okay. And I will use the technique for because from example we know X bar and S already. You do input X bar and S. If you don't know, you can put X data in the spreadsheet. Okay. Go to the that basic and for this get one simple T, not C. Because we use T distribution. Okay. One simple T. Okay, we should T. And then if you have the data in column, you click this. Right. You have data in this, you click this, but for this I will show summarize data. You summarize data, that means you know X bar already, you know variance already. For example, if you don't know, you can choose this, and then you click this data. Okay. But then for this get one simple T, yes. Oh, something wrong. Okay, this slide wrong. The next slide correct. Next slide correct. Because you found that the result is T. Sorry. I do this last night. Sorry. Okay, you look at this T, right? That's correct. But maybe something wrong when I cut it. When I cut it. But it should be this. will be P. So this is P. You should collect one simple P, not sample. P distribution. We use the summarize data. If you put all data, you should get one column. Like for example, I will have some. Okay. พักเบรกไปด้วยการพิมพ์ก่อนโอเค 0.8411 0.8191 0.81S2 0.125 0.875 0.8580 0.8532 0.8482 0.8276 0.9783 0.8002 0.873 0.8282 0.8351 0.860 Okay, we have the data in spreadsheet. 15 data. I'm not sure if correct or not. Okay, and then you go to the statistics. One simple T, right, for example. And then we should one or more sample and you click this, double click, you input your data. Right, double click or you click this and select output. And then to take a double click or click one time and select. Okay, we use this data for hypothesis. Yes, that's right. The hypothesis mean for this case 0.82, right? Hypothesis mean. And then we would like to test with 0.05 for alpha, that means 95%. And have three choice, for this case is better than right? Mean is better than hypothesis. Right. And then, okay. And also summarize that. We would like to test that on mu equal to 0.82 or greater than 0.8. And for this case, we calculate mean. This is mean. This is standard deviation. It calculates for you. That's what it calculates for you. And this is we calculate the 95% confidence is low bar like this. And T distribution is 2.728%. That's fine. And P value is 0.008 is less than 0.05 is reject. You reject because P value is less than alpha. If you use technique, this program will calculate mean of this data, calculate standard deviation of this data for you also. And also calculate SED. SED is standard deviation divided by square root. And also the 95% confidence interval is one time. 0.2. Okay. Because the standard is 0.82 less than this, you reject. If you check the confidence interval like this, this is the lower bar is 0.8266 for your sample, but your spec 0.82 that is less than the lower bar. That you reject. Okay, that you reject. Or you use the P value is less than alpha, you reject also. Okay, do you have any comment? For this set again, thank you for your comment because I have something wrong. Okay, we take a picture. we capture it wrong. And the next one is correct. Okay. And also we use it to calculate the sample size. The sample size for this we use the curve. We use the curve. We have to know the difference, like mu minus mu zero divided by sigma. And you can use any curve. At the same with d and beta with curve. D and beta for different alpha and for different alpha. For different alpha. Okay. For this case you know n, you calculate beta. If you know beta, calculate it. You also use the power for this. Okay, we calculate. We check for you. Okay, for this case we calculate power. Where power is mean 1 minus beta. 1 minus beta. This correct, okay. This one system. In the same, you go to the stat, but for this case, we go to power and sample size. For this, we would like to calculate power and sample size. If you would like to test, you go to the like this. For this case, we go to power and sample size. Also, we have one simple thing. One simple thing. For this case, you know sample size is 15. You know difference is 0.81. 0.81. You would like to calculate power. You would like to calculate power. You know the standard weight is 0.02456. And also for this case, we take based on greater than not. We choose greater than. We take based on greater than 0.05. And then it's conclude for you, right? The power is 1 for this. The power is 1. I have to break for 10 minutes. Right, for the next we talk about the variance and proportion. And after this, we talk design experiment. For this, we only review about the statistics for hypothesis test or confidence interval. And the next topic we focus on experimental design, the technique for experimental design and the technique for fit equation. So this is the next week. Okay, stop.